Right. Welcome to Abhiram IAS Academy. In our last sessions, we discussed about number systems and we solved some of the previous year's problems and all those things in our previous sessions, right? So today in this session, we will solve one of the most important concepts, that is permutations and combinations. See students, most of the students were not even trying to attempt the questions from permutations and combinations. The major reason is they don't know what is the actual concept behind that. But they are asking questions in such a manner that there is a blend of questions which mixes the number systems and permutations and combinations. So if you are really good in permutations and combination, you can also solve some of the questions from number systems very effectively and easily. Okay, so today we will see the same thing, the permutations and combinations. We will learn the entire permutations and combination concept, and then we will see the questions from number systems which are related to permutations and combinations, right? Next. Now, when it comes to these permutations and combinations, students, right, we will see. What is called permutations and combinations in general? In general means the technical terms are permutations and combinations, but permutations means arrangements. When it comes to combinations, combination means selection or choosing. Okay, so please try to understand this concept, students. Permutations means arranging, whereas combination means selections or choosing the people. So if you understand this major difference, then you can say when you can apply permutations and when you can apply the combination. So to arrange certain number of people, or to arrange some letters, we will use the concept of permutations. When it comes to combinations, to choose certain letters or to choose certain people from a group of people, we call that as combinations. Now, what is the difference between these permutations and combinations in general? We will see. For example, there is a word called eat. If I want to arrange the letters of the word eat, in how many different ways I can arrange it? In how many different ways I can arrange the letters of the word eat means, see here, I can write it as EAT, eat, or I can write it as ETA, or AET, or ATE, or TEA, or TAE. So we can write in these many different ways. The letters of the word eat can be arranged in how many different ways? In 6 different ways. In 6 different ways. So this is called permutations. In 6 different ways. So as this is a 3-letter word, there is no problem for us. We simply written all the possible arrangements and we counted it and we written our answer as 6. But in general, if it is not a 3-digit word, something like mathematics or a word like that. So how we can do that one? We cannot write each and everything in the same manner. Practically it becomes very difficult for us to do so. So to avoid this, what we do, we will use a formula that is called permutation formula, which is NPR. And so in this manner we can do the NPR. So what is this NPR and how we will do later while solving the problems, we will know. But generally permutations means arranging the things. Arranging whether it can be letters or persons, whatever it may be. But in our cases, most of the time they will ask questions based on letters only. Okay, arranging the letters of a word or any person, something like that. We will see that later for timing. Next, when it comes to combination. In generally, what is meant by combination means, for example, in a bag, I have some 3 balls, A, B, and C. A, B, and C. Okay, now when I want to draw 2 balls from this, bag, in how many different ways I can do? I can draw either AB, or I can draw AC, or I can draw BC, or I can draw BC. Now in this case, the order is not important. See, when it comes to arrangement, anyway we are using the same 3 letters. But which letter we are using first, which letter second, and which letter third, that is very, very important in case of arrangement. But when it comes to combinations, there is no rule that which ball is taken out first. That means whether A is taken out first or B is taken out first. And similarly, whether I have taken A first or C next. And similarly, just simply we need to pick 2 balls. That is enough. Whether you take first A, next B, or first B, next A, it doesn't matter for us. So in how many ways we can choose means, in 3 different ways we can choose. Understood, student? That is the difference between our permutation. In permutations, please be careful which one we are writing first, which one we are writing next, which one we are writing last. That is very, very important. That is nothing but the arrangement. But when it comes to combinations, which one we are picking first, which one we are picking next, this is not that much mandatory. Okay, generally we will observe that is enough. Okay, this is the major difference between permutations and combinations. Okay, good, done with this. Now we will have two formulas actually. One is NPR, the other one is NCR. We will first of all learn the basics of this NPR and NCR, how we are going to solve, and then we will move to the actual concept. Why? Because if you know some shortcuts, we will get the answers very quickly, students. Okay, so first of all, we should know those things, and then we will come to the problems. Now, first and foremost thing, factorials. You should know how to write the factorials. In general, how we will write the factorial? N factorial means n into n minus 1 into n minus 2 into n minus 3, and so on up to we will write 1. Up to we write 1. So we will write the product of numbers like this. And when it comes to this factorials cancellation, see here students, whenever you have something like this, 8 factorial by 4 factorial, 8 factorial by 4 factorial, you cannot cancel and write it as 2 factorial. This is wrong. You should not do cancellation in factorials. How you can cancel them? Means see here, if I have 8 factorial by 4 factorial, how I can cancel it is 8 into 7 into 5 into 6 into 4 factorial. Sorry, 6 into 5 and 4 factorial. 6 into 5 into 4 factorial by 4 factorial. Now you can cancel 4 factorial with 4 factorial. There is no wrong in that. But don't cancel directly 4 factorial with 8 factorial and write it as 2 factorial. That is a mistake. Okay, you should not do that one. So now the answer will become 8 into 7 into 6 into 5. Understood? In this manner, you need to cancel the factorials. Factorials. Most of the student knows, but still I want to clear this small doubt. Why? Because in examination in a flow, some students may do this mistake. So please be careful with this. And the next one, NPR. We will use the formula NPR. NPR means n factorial by n minus r factorial. NPR means n factorial by n minus r factorial. There is nothing more to learn in this one. But when it comes to NCR, please observe here students, NCR means n factorial by n minus r factorial into r factorial. NCR means n factorial by n minus r factorial into r factorial. So for this you should have some basic knowledge. Okay, to solve this NCRs, there are some shortcuts which we will use directly while solving the problems. That is the reason I am telling that one priorly. What it is, for example, if I want to write 10C8, if I want to find the value of 10C8, in general, 10C8 or else I will take 10C2. We will go with a small number. 10C2. 10C2. Okay. So what is the actual process? n factorial by 10 minus 2 factorial into 8 factorial. Sorry, 10 minus 2 factorial into 2 factorial. 10 minus 2 factorial into 2 factorial. That is the thing, right? Now, when we solve this one, what will happen for us here? 10 factorial by 10 minus 2 factorial is what? 8 factorial into 2 factorial into 2 factorial. Now what happens to this numerator? 10 into 9 into 8 factorial. I can write it as 10 into 9 into 8 factorial by 8 factorial into 2 factorial. Now see here students, I can cancel 8 factorial with 8 factorial and directly I can write it as 10 into 9 by 2 factorial means 1 into 2. So 10C2 means what? 10 into 9 by 1 into 2. 10 into 9 by 1 into 2. Okay, good sir. Now what I mean to say here is, if you have something like this 10C3, how you will write this one means, decrement this 10 for 3 times. 10 into 9 into 8. 3 numbers, up to 3 numbers, 1, 2, 3. And write 1 into 2 into 3. Okay, don't write this formula and do all these things. It is waste of time. If you want to find 10C3, 10 into 9 into 8 by 1 into 2 into 3. Similarly, if you want to write something like this, 7C3, then how you are going to write that as 7 into 6 into 5. 7 should be reduced for 3 times by 1 into 2 into 3. Directly you can write it as 1 into 2 into 3. Understood, students? 7C3, we will write it as 7 into 6. For example, if I want to write something 8C2, then what I am going to do? 8 into 7 by 1 into 2. 8 into 7 by 1 into 2. If I want to write something like this 6C3, then what I will do? 6 into 5 into 4. I will reduce it for 3 times, and next 1 into 2 into 3. Understood? This is the shortcut to write the combination formulas. Okay, combination formulas. No need to do all these things and solve and you will get the final answer. Directly try to write in this manner. Try to write in this manner. Next, there is one more thing. For example, sir, okay, good, everything is fine. If I have something like this, then how I am going to get the answer? A thing like 10C8. 10C8. Just now I told you, right? Based on this base, you reduce it. So, sir, should I do in this manner? 10 into 9 into 7, 8 into 7 into 6 into 5 into 4 into 3 by 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8. Should I do this one? No, you should not do this one. The other method for this one is, see here, 10C8 value will be equal to 10C2. 10C8 value will be equal to 10C2 if you observe carefully. What you need to do is, if it is easily solvable, you solve it. Else, 10 minus 8 is what? 2. So, this will be equal to 10C2. 10C2. So, for this we have a shortcut formula. What is that formula is? NC2, NCR or else NC2, whatever it is. NCR will be equal to NCN minus R. NCR value will be equal to NCN minus R. NCR value will be equal to NCN minus R. That means if I want to write 9C8, 9C8 value will be equal to 9C1. 9 minus 8 is 1, so 9C1. Okay. Similarly, if you have something like this, 7C5, this value equal to 7C2. 7 minus 5 it is 2. Okay. 7C5 value will be equal to 7C2. So, these are the things which you need to observe before going to this concept, permutations and combinations, students. So, NCR I can write it as 9C8, I can write it as 9C1. 9 minus 8 it is 1. 7C5 I can write it as 7C5. 7C2, sorry, 7C2 I can write it as 7C5 or 7C5 I can write it as 7C2. There is no wrong in that. Anyway, both the values will be same. If you want to verify it, just verify it. You will get the same answers for both the things if you go with the standard procedure. But in general, to save some time in the examinations, directly don't write 7C5. 7C5 value will be equal to 7C2. Don't worry, while solving the problems, once again we will discuss them. And some standard things are something like this. 7C7 value will be equal to 1. That is nothing but indirectly NCN value will be always equal to 1. NCN value will be always equal to 1. And similarly, NC1 value will be always equal to N. So, please try to observe these things. Okay, NC1 value will be equal to N. Why? Because N by 1. Only we should reduce it for, you should write it for only once, right? So, N by 1. Okay, next NCN means N by N. So, what you will get? Everything will be cancelled. You will be left with 1. You will be left with 1. And one more thing, we should know that 0 factorial is equal to 1. Before going to this concept, 0 factorial we will consider it as 1. 0 factorial we will consider it as 1. So, these are the basic things which we should know before solving the questions of permutations and combinations. I hope everyone understood these concepts. Okay, first and the two formulas are what? First it is NPR. NPR will be equal to N factorial minus by N minus R factorial. Next we will have NCR. NCR will be equal to N factorial by N minus R factorial into R factorial. So these two things, permutations and combinations. NP means permutations, NC means combinations. So if the question is belonging to permutations, usually we will use the formula NPR. If the question belongs to combinations, we will use the formula NCR. NCR. Understood, students? And these are the shortcut techniques to get the values for this NCR. Okay, now we will go to our concept. Now see here, what is permutations? Anyway, very rarely we are going to use these formulas. In some exceptional cases, we will try to solve in a generalized manner. But for your knowledge, out of n different positions, R elements can be arranged in. Now here there will be two cases, with repetition and without repetition. What is the difference between this with repetition and without repetition means? See here students, let me take a new page. Okay. Now with repetition and without repetition, what will happen with the with repetition and without repetition means? If just now we have seen eat, right? In how many ways we have written this eat? In 6 different ways. And that is without repetition. With repetition means, the meaning of with repetition is, I can use the letter E for 3 times, or I can use the letter E for 2 times. E-E-T I can use, or else I can write as E-A-E, or else A-E-E, or else I can write as E-T-E, or else T-E. And I have taken only the repetition for E. I can similarly I can do the repetition for A. Similarly, I can do the repetition for T. So, now what happens to this one is, how to avoid this confusion and all those things means, see here students, in the case of without repetition, see this is without repetition. Without repetition. Okay. So total how many letters are there for me? 3 letters are there for me, right? Total how many letters are there for me? 3 letters. Now without repetition means, if I use this E for once, I cannot use A and T. If I use A for once, I cannot use A once again. So for the first letter, for the first position, this is first position, second position and third position. First position, second position and third position. For the first position, how many chances do I have actually here? E-A-T. I can use any one of these 3 letters, right? I can use any one of these 3 letters. So how many chances are there for me? 3 chances to fill my first position. I can fill E, A or T. Now when it comes to the second position, how many chances are there for me to fill the second position? Already 1 letter is filled at first position. It can be either E, A or T. Out of 3, 1 is filled at first position. Now I will be left with more how many letters? 2 more letters. It can be any 2. So for second position, how many chances I will have? 2 chances. For third position, how many? Already 2 letters are filled. The leftover will be left for me. So for the third position, how many chances I will have? 1 chance. 1 chance. So total, these are chances, students, actually. Okay, these are chances. 3 chances, 2 chances. So total number of ways means 3 into 2 into 1, which in term we can also write as 3 factorial. 3 into 2 into 1, we can also write it as 3 factorial, right? So 3 into 2 into 1, what it becomes? 6. So total it can be written in 6 different ways. So this is the understanding which we should know. Okay, the letters of the word eat can be written in how many different ways? 6 different ways. And how we should think means, for the first position, how many chances I will have? Out of these 3 letters, I can pick 1 letter. So 3 chances. For the second position, out of these 3, already 1 is filled at the first position. So we are left with 2 more. So 2 chances, and for the third position, 1 chance. Okay, so 3 into 2 into 1, which will be equal to 3 factorial, which will be equal to 3 factorial indirectly. So 6 different ways. Now, with repetition. Now repetition is allowed for me. That means I can use the letter E for 3 times, 2 times, A for 3 times, 2 times, whatever the number of times I can use it. So now I have first position, second position and third position. Now in my first position, I can fill any one of those 3 letters, right? So how many chances I will have in the first position? 3 chances. Now when it comes to the second position, repetition is allowed, right? If already E is used, I can use it once again. Repetition is allowed. So once again, I can take 3 chances for my second position. For the third position also 3 chances. Right? So what will be my answer now? 3 into 3 into 3. Which will be equal to 3 cube. Which will be equal to 3 cube. So with repetition means what we will take? Directly 3 factorial or 4 factorial, whatever the number of letters. Without repetition means this is the case. With repetition means this is the case. We should understand. So I hope everyone understood these chances. This taking chances is very, very important for us. So try to understand this concept. Now, with this understanding only we are going to solve almost all the problems. Very rarely we will use the formula NPR. Very rarely we will use the formula NPR, but in most of the cases we will try to solve the problems with this concept only. For first position how many chances, second position how many chances, like that only. Understood, students? Now we will see the formulas. See here, out of n different positions, that means it will have 3 different positions, 3 letters. If R elements can be arranged without repetition, the formula is what? NPR. In NPR ways we can do that one. In NPR ways. NPR means, see, for example, in the word eat I have 3 chances, so I should fill it with 3 letters. So what it becomes indirectly, please observe here, students, 3 factorial by 3 minus 3 factorial, which in turn becomes 3 factorial by 0 factorial. Just now I told you 3 factorial. So if you go with the formula also, you will get the same answer. You will get the same answer, but in general, very rarely we are going to use the formulas. We will try to solve the problems by this understanding only. Okay, right? With repetition, just now we have seen what we got, 3 cube. So here also the same thing, 3 cube, r to the power of n, r to the power of n. And when it comes to combinations, the same thing, we will use NCR. With repetition in combinations is very rare, students. To be frank, they are not going to ask this with repetition. Why? Because if there are 5 persons, how I can pick it for him for multiple times? Actually, is it possible? Not possible. There will be some rarest of the rare situations where we will use this formula, but no need to worry about this one, students. Okay, just for formula sake, for your knowledge sake, I have given. Very rarely they are going to ask these questions. No need to worry about this with repetition case in combinations. Now directly we will move to the problems and try to understand our permutation concept. Right, see here, in how many ways the letters of the following words can be arranged without repetition? See here, students, most of the cases we will write without repetition. If it is required, we will try to solve it with the help of with repetition. Now without repetition, total how many letters are there? 1, 2, 3, 4, 5 letters are there for me here. Okay, good, superb. So 1, 2, 3, 4 and 5 positions are there. So for my first position, how many chances are there? First, second, third, fourth, fifth. How many chances are there for my first position? Actually, 5 chances are there. Why? Because I can use any one of the 5 letters. Okay. Next, for the second position, only 4 chances. Why? Because already I used 1 here. So I will be left with 4 more letters. So for third, 3. For fourth, 2. And for fifth, 1. Which is indirectly what? 5 factorial. That means I need to multiply them. 5 into 4 into 3 into 2 into 1, which becomes what? 5 factorial. I think in 2021 or 2020, they asked the question regarding Delhi by using the word Delhi. In how many ways the letters of the words Delhi can be arranged? So this is more or less the same question. So 5 letters and all the 5 letters are different letters. So directly you can say that this can be arranged in 5 factorial ways. 5 factorial ways. 5 factorial means what? Actually, 5 factorial value will be equal to 120. 120. Okay. So 5 factorial, which is equal to 120 ways. That means we can arrange the letters of the word mouth in 120 different ways. 120 different ways. In 2022 or 2021, they asked this question about Delhi. Right? Now see here, in how many different ways the letters of the word family can be arranged? 1, 2, 3, 4, 5, 6. 6 letters are there and all the 6 letters are different letters. So no need to worry. Directly I can say that I can write them in 6 factorial ways. I can write it in 6 factorial ways. Next, when it comes to exam, in how many different ways we can write the letters of the word exam? See here, 1, 2, 3, 4. So we can write it in 4 factorial ways. We can write it in 4 factorial ways. Next, crystal. How many letters are there? 1, 2, 3, 4, 5, 6, 7. So in 7 factorial different ways we can write the answer for the crystal. Next, education. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 factorial ways. See students, just for your knowledge sake I have given this example. So directly I am writing these things. Okay, understood? So in all these examples, if you observe carefully, is any letter repeated in these examples? No letter is repeated. Sir, if any letter is repeated, then what will happen? For example, earlier I have taken eat, so I said that I can arrange them in 6 different ways. For example, if my question is something like I, Then in how many different ways I can write the letters I? Actually, see here students, 1, 2, 3. Okay, either I can write EYE or else EEY or else YEE. Apart from this, can I arrange in any other different ways? No, I cannot arrange them. Then sir, how we need to solve? These type of questions means, see here, whenever there is a repetition, immediately we will have a denominator. So the letters of the word I can be arranged in, first of all count it 1, 2, 3, how many ways? 3 factorial ways in general. But the letter E is repeated for twice, right? So by 2 factorial. E was repeated for 2 times, so I will write it as by 2 factorial, Why? Because E is repeated for 2 times. So 3 factorial by 2 factorial, what it becomes actually students? 3 into 2 factorial by 2 factorial. I will cancel these 2. In how many ways I can write in? I can write them in 3 different ways. Understood? Now we will see the set of questions where we will have this repetition. Now see here. In how many ways the letters of the following words can be arranged without repetition? See, letters are repeated in the word. We should not repeat it once again. So now please see here. In how many ways we can write the letters of the word matter? Generally, count it first of all. 1, 2, 3, 4, 5, 6. Okay, so if there is no repeated letter in the given word, you can write it in 6 factorial ways. But here T is repeated for 2 times, right? So what you will write? 6 factorial by 2 factorial. 6 factorial by 2 factorial. Why? Because T was repeated for 2 times. Next, percentage. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total how many are there for me here? 10 letters. So 10 factorial ways. But here I have some repetition, right? What are those repetition? E was repeated for 3 times. E was repeated for 3 times, so I will write it as by 3 factorial. Is there any other letter repeated in this word? No, it is not repeated. Only E was repeated for 3 times, so I will write it as 3 factorial. Now please observe the word letter. 1, 2, 3, 4, 5, 6. 6 factorial by, please observe here E was repeated for twice and T was repeated for twice. Don't add 2 plus 2 and write it as 4 factorial. Write them individually. How many letters are repeated? Write them individually. So E was repeated for 2 times, so 2 factorial. T was also repeated for 2 times, so I will write it individually 2 factorial. Don't write 2 plus 2 as 4 and write it as 4 factorial. That is wrong. Okay, write them separately. Now similarly try to write the answer for these two. Corporation and engineering. Pause the video for a while and try to write the answer for this. Okay, now see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 only, right? 3. Okay, 11 factorial. Good, superb. Now please see here O was repeated for 1, 2, 3. 3 factorial. Next R was repeated for 2 times. 2 factorial. Next, is there any other repetition here in corporation? O and R. Apart from O and R, no other letter is repeated. So 3 factorial into 2 factorial. Now come to engineering. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so total 11 are there. So 11 factorial by E was repeated for how many times? 1, 2, 3. 3 factorial. Next N was repeated for 1, 2, 3. 3 factorial. Next G was there for 2 times. So 2 factorial. I was there for 2 times. So 2 factorial. This is for E. This is for N. This is for G. And this is for I. So is there any other? Only R is there. Now my answer will become 11 factorial by 3 factorial into 3 factorial into 2 factorial into 2 factorial. Write them individually, students. Write them individually. Okay, understood? Now I think everyone understood what is this arrangement. How we need to arrange means by this simple process. Okay, the reason behind that already I told you why we are writing 6 factorials and all those things means actually we will write it as 5 into 4 into 3 into 1. Chances. We will write the chances. So that chances is nothing but 5 factorial. When you multiply it becomes 5 factorial. So directly we are writing our answers in factorials. But students remember in examinations they are not going to give the answers in factorials. Very rarely it will happen. Usually the solved answers will be there. So you know how to solve the factorials. It is waste of time in discussing how to solve the factorial values. 6 factorial means what? 6 into 5 into 4 into 3 into 1. You people know it. Now all these examples we have written with what? Without repetition, right? Anyway, the question is also without repetition. For example, if we came to this one, right? We will see that one also parallelly. If the question is, if repetition is allowed, then what will happen for mouth? 5 to the power of 5. Why? Because 5 places are there and 5 letters are there, 5 to the power of 5. What happens to family? 6 to the power of 6. If repetition is allowed. This will not be asked, but for your knowledge sake, I am telling. So, exam can be written in 4 to the power of 4. Crystal can be written as 7 to the power of 7. When repetition is allowed. Remember, when repetition is allowed. This will become what? 9 to the power of 9. 9 to the power of 9. So, all these answers are what? When repetition is allowed. When repetition is allowed, we will get the answers in this manner. For the same examples, if repetition is allowed, what you will get here? 6 power 6 by 2 factorial. As usual. See students, in our this permutation concept, whenever the letters are repeated for multiple times, immediately we will have the denominator. Keep that thing in your mind. That's it. Nothing more than that. If repetition is allowed in this case, what you will write? 10 to the power of 10 by 3 factorial. If repetition is allowed in this case, what you will write? 6 to the power of 6 by 2 factorial into 2 factorial. Understood? And similarly, we will write the answers for this one. So without repetition only they are going to ask in 99.99% cases. In worst case, if they ask you questions based on repetition, then this is the way to write the answers for those repetitions. Okay, right? We will see the next set of questions. In how many ways the letters of the word mouth can be arranged such that always the vowels come together? This is a special case for us. Okay, the word for us is mouth. What they are telling is always the vowels should come together. That means what are the vowels which I have in mouth? O and U. We all know what are the vowels? A, E, I, O, U. So total 5 vowels we will have. In this word we will have only 2. We have only 2 letters, O and U. O and U. So what is our condition is here? Always O and U should come together. That means if O and U should go here, 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 whenever they move, O and U should move together. So what I will do is MTH. I will write all the consonants one side and I will take O and U as a group. Why? Because this vowel should come together, right? That means it should move OU, OU, OU or UO, UO, UO. Okay. So as a group means now I will consider this group as a single letter. So now 1, 2, 3 and how many letters are there for me? 4 letters are there. 4 letters can be arranged in how many different ways? Just now we have seen 4 letters can be arranged in 4 factorial ways. Okay, good. 4 factorial ways. And come to this O and U. Why should be like O and U? It can also be like U and O. UO also can be written, right? You can also write it as UO. Why only O and U? You can write it also as UO, right? So this U and O can be arranged internally in how many ways? In 2 factorial ways. Okay, so the letters of the word mouth can be arranged in 4 factorial into 2 factorial ways such that always the vowels will come together. Vowels, I am making it into a group. Now I am considering these vowels as a single letter. Why? Because they always come together. So if O moved, obviously U also should come with O. That is the case, right? So 1, 2, 3, 4. 4 letters can be arranged in how many ways? In 4 factorial ways. 4 letters can be arranged in 4 factorial ways. So 4 factorial into O and U can be arranged in 2 factorial ways internally. Okay. So 4 factorial into 2 factorial. 4 factorial into 2 factorial. Right? Now we will see some examples. Now see here, in how many ways the letters of the following words can be arranged such that always vowels come together. Our first question is what? Machine. Just now we have seen how to write the vowels come together case. First of all, write the consonants. What we have here? M, C, H, N. M, C, H, N. And what are the vowels I have here? A, I, E are the vowels I have here. Now I will consider this vowels group as a single letter. So how many letters are there for me? 1, 2, 3, 4 and 5. 5 letters can be arranged in how many ways? We already seen 5 letters can be arranged in 5 factorial ways. Good. Now this AIE can be internally shuffled. In AIE can be arranged in how many ways? They can be arranged in 3 factorial ways. See students, what is this AIE internal arrangement means? It can be AIE, it can be AEI, it can be IAE, it can be IEA, or else EAI, or else EIA. They can be arranged in this manner also, right? They should be together, but they should not follow any particular order, right? Did they mention us they should follow any particular order? No. They can be once again internally arranged in how many ways? 6 ways, which is in other terms I can say it as 3 factorial. That is the reason I am writing it as 3 factorial. Understood? So vowels I am taking it as a group, and I am writing all the consonants first and vowels as a group. Now that vowel group I will consider as a single alphabet. So 1, 2, 3, 4, 5, they can be arranged in 5 factorial ways, and these vowels internally can be arranged in 3 factorial ways. Understood? Right. Now try to write the answer for these remaining things. Pause the video for a while and try to get the answers for this one. So when it comes to marble, what you can write for marble? MRBLAE. 1, 2, 3, 4, 5. 5 factorial, and A and E can be internally arranged in 2 factorial ways. Okay. Next, learn. LRNEA. 1, 2, 3, 4. 4 factorial into E and A can be arranged in 2 factorial ways. Education, what you can write? DCTN. EUAIO. In education we will have all the vowels. So now please see here 1, 2, 3, 4, 5. So this can be arranged in 5 factorial ways, and these vowels internally can be arranged in 5 factorial ways. So 5 factorial into 5 factorial. Okay, next when it marble, it was repeated for twice, no need to worry. Okay, right? In this manner you need to write the questions that vowels should always come together. Now the examples which I have taken is, in this there is no repeated letter. All the letters are there for only one, so there is no problem. Now we will see another set of examples. Now see here, same question, but here the letters are repeated. No need to worry, the same process students. There is no difference. So SSTRIE as a group. So now 1, 2, 3, 4, 5. So 5 factorial ways into I and E can be written in 2 factorial ways by, whenever you have the letters repeated, so by 2 factorial. Why? Because S was there for 2 times. S was there for 2 times, so I will take it as 2 factorial. Next, animation. What you will get for animation? NMTN. AIAIO. These are the vowels which I have here. Students, definitely you should write all the letters. If they are repeated also, don't forget to write. If you have any doubt, count them once again. 1, 2, 3, 4, 5, 6, 7, 8, 9 are there. 1, 2, 3, 4, and here 5, total 9 are there. All the letters should be written first, definitely. Now see here, 1, 2, 3, 4, 5. So they can be written in 5 factorial ways. Into these vowels can be arranged internally in 5 factorial ways. Why? Because 5 vowels are there. By now repetition. N was there for 2 times, so 2 factorial. A was there for 2 times, so 2 factorial. I was there for 2 times, so 2 factorial. Understood? This is the process. Next, preparation. PRTN, and vowels EEAIO. So 1, 2, 3, 4, 5, 6, 7. This total group I am considering as the 7th letter. So 7 factorial into 5 factorial by P was repeated for 2 times, so 2 factorial. R was there for 2 times, so 2 factorial. E was there for 2 times, so 2 factorial. Preparation. Similarly, please find the answer for the corporation also. What you will get for corporation? CRPRTN. Sorry, TN. So what I have here? OOAIO. OOAIO. So now what happens to this? 1, 2, 3, 4, 5, 6, 7. Okay, 7 factorial into, these are 5 in number, so 5 factorial by repetition. R was there for 2 times, so 2 factorial. O was there for 3 times, so 3 factorial. 2 factorial by into 3 factorial. So this is the process. Vowels come together. Vowels should always come together, means this is the process. This is the process. Now similarly, next one. In how many ways the letters of the following words can be arranged such that always the consonants come together? See here, earlier what it is? Vowels come together, right? Now here it is consonants come together. So now what we are going to do? We are going to make consonants as a group. We are going to make consonants as a group. So what we will write here? First, in that case what we have done, we have written all the consonants first, right? So in this case we should write all the vowels first, A and E, and consonants as a group. Consonants as a group. Now please observe here, 1, 2, 3. So 3 factorial, and W2R can be arranged in 3 factorial ways. Why? Because 3 letters, 3 factorial ways. Understood? Is there any repetition? No repetition, so no denominator. That's it. Now come to animal, AIA, NML. 1, 2, 3, 4. 4 factorial into 3 factorial by, here A was repeated for 2 times, so by 2 factorial. Next color, OUCLR. 1, 2, 3, 4. So 4 factorial into CLR can be written in 3 factorial ways by O was repeated for 2 times, so 2 factorial. 2 factorial. Now cricket, IE are the only vowels we have. So CRCKT. 1, 2, 3. So 3 factorial into this 5 can be arranged in 5 factorial ways by, here C was repeated for 2 times, so by 2 factorial. In this manner, we will write the always vowels come together or consonants comes together. This is the case. This is the case. Understood, students? Right. Now we have one more different case in this one. Next one's here. In how many ways the letters of the following words can be arranged such that always the vowels should not come together? Should not come together. In our previous examples, what we have seen, vowels should come together. Should not come together means what? We can say that total minus always together. I can do this one, right? Total number of ways minus always together. Total number of ways minus always together. Total number of ways minus always together. Now first of all, what is the total number of ways for me here? MACHINE, all are different. 1, 2, 3, 4, 5, 6, 7. So 7 factorial minus vowels should come together. Always come together means what I will do? MCHNAIE. 1, 2, 3, 4, 5. 5 factorial into this AIE is can be arranged in 3 factorial. So my answer will become what here? 7 factorial minus 5 factorial into 3 factorial. Understood, students? Vowels should not come together. This is the case of vowels should not come together. So total minus always come together. Negation, right? Negations. This is negation. So similarly, prison, what will happen for prison, students? What will happen for prison? 1, 2, 3, 4, 5, 6. Okay. Total number of ways is 6 factorial minus 6 factorial minus. Now please see here. P, R, S, N, I and O. 1, 2, 3, 4, 5. 5 factorial, and IO can be arranged in 2 factorial ways. So total minus always come together. Okay. Next, when it comes to matter, 1, 2, 3, 4, 5, 6. 6 factorial by T was repeated for 2 times, so 2 factorial minus. Similarly, MTTR AE. 1, 2, 3, 4, 5. So 5 factorial into AE can be arranged in 2 factorial by 2 factorial. You can also take whole by 2 factorial. Why? Because anyway we will get the same denominators here. Same denominators here. You can also write whole by 2 factorial, but for better understanding I have written separately. Similarly, write the answer for corporation also, students, by yourselves. Please write the answer for corporation by yourselves. Next one. Now see here, no 2 vowels come together. Sir, what is the difference between this no 2 vowels come together and all the vowels should not come together? The meaning of that is, See here students, with one example I will explain you. Machine. I will tell you three categories. Vowels come together. You should understand this one carefully students. Vowels come together. Vowels should not come together. Come together. And the last category is no two vowels come together. What is the difference between? Anyway, we know the difference between these two, but we should know the difference between these two. Machine, vowels come together means what I told you, M, C, H, N, and always A, I, E should come together. A, I, E should come together. That is good, really good. Now, vowel should not come together means M, C, H, A, I, E, N, E. Like this also vowels are not coming together, right? That means any two can come together. See, vowel should not come together means if two vowels can come together, right? Then also I can say that in this case vowels are not coming together. Vowels are not coming together. So this is vowel should not come together. Why? Because E is not with AI. E is not with AI. So this is the case of vowel should not. So we can consider this as vowel is not coming together. Vowels are not coming together. Vowels are not coming together. Now come to the third one. No two vowels come together means definitely no two vowels should be side by side. That means MCA, H, I, N, E. That means all the vowels should come individually. All the vowels should come individually. They should not come together. They should not come together. So try to understand the difference between these two students. Vowels not coming together and no two vowels come together. See, this one is vowels not coming together. Why? Because all the vowels, are all the vowels coming together? No. Only A and I are coming together. So I can consider this under vowel should not come together. No two vowels come together means this is the case. That means any vowel should not be side by side. Side by side. Not only all, any two should not be together. So this comes under no two vowels come together. I hope you understand the difference between these two. Now we will solve our problems. Now we will solve our given problems. Right. Now see here, in how many ways the letters of the word mother can be arranged. So vowels should not come together, right? No. So first arrange the consonants. When you arrange consonants, M, T, H, R are the consonants I have, and vowels I have are O and E. Now I can arrange O here, 1, 2, 3, 4, 5. So so how many vacant places I have here for me? I have 5 vacant places here. I have 5 vacant places here. So I can place this O and E wherever I want. I can place this O and E wherever I want. Now here in this case, we will take the help of formula. We will take the help of formula. First of all, MTHR can be arranged in how many ways? In 4 factorial ways. Why? Because why only I should write it as MTHR? It can be TMHR also, right? So MTHR can be arranged in 4 factorial ways. Good, superb. Now how many vowels are there for me? O and E. 2 vowels are there. These 2 vowels should be arranged in how many places? 1, 2, 3, 4 and 5. So I have 5 places. I need to arrange these 2. That means I can arrange them in how many ways? 5p2 ways. I can arrange them in 5p2 ways. Here we are going to use the formula. For the first time we are going to use the formula here. That means 4 factorial into 5p2. 5p2. So what happens to this 4 factorial into 5p2? 4 factorial is 24. 5p2 means I told you what we can do. 5 factorial by 3 factorial. 5 factorial by 3 factorial. So which in turn we can write as 24 into 5 into 4 into 3 factorial by 3 factorial. 3 factorial, 3 factorial get cancelled. So 24 into 20. What you will get? 480. So I can write them in 480 different ways. Such that no two vowels come together. Such that no two vowels come together. No two vowels come together. Next, machine. Please see here. First write down all the consonants M, C, H, N, M, C, H, N. That's it, right? So what are the vowels I have here? A, I, E. So these are 3 and those are 4, 7. Total is also 7. Now please see here how many gaps I have. 1, 2, 3, 4, 5. How many gaps I have? 5 factorial. So first of all, machine can be arranged in MCHN can be arranged in 4 factorial ways into, in these 5 gaps I need to fill these 3 vowels, so 5p3. So 4 factorial into 5p3, 4 factorial into 5p3. Next banker. So here what are the consonants I have? BN, KR, and what are the vowels I have? AE. So first of all, BN, KR can be arranged in 1, 2, 4 factorial ways, and I have 5 gaps, 5p2. In 5 gaps I need to fill with these 2 vowels, 5p2. Next computer, so CMPTR, 5 are there. OUE are the 3 vowels which I have here. So CMPTR. How many gaps? Gaps will be 1 more than these letters, students. No need to count each and every time. 1, 2, 3, 4, 5, right? So 5 factorial. And the number of gaps will be 1 more than this. So gaps will be 6 here. So in that 6 I need to arrange this OUE. So 6p3, 5 factorial into 6p3. Now come to this sister. First of all, SS, TR and I and E. So as usual, SS, TR I need to arrange, and 4 letters, so 4 factorial. How many gaps we will have? 5 factorial, so 5 gaps, so 5p2 by S was repeated for 2 times, so 2 factorial. Whenever there is repetition, immediately we will have the denominator, students. Okay, immediately we will have the denominator as 2 factorial. Now see the answer for permutations. What are the letters we have here actually for permutations? P, R, M, T, T, N, S. And what are the vowels I have here? E, U, A, I, O. Okay, so please see here. 1, 2, 3, 4, 5, 6, 7. 7 factorial into 7 letters means how many gaps we will have? 1 more than 7 means 8. So in that 8 I need to fill this 5. So 8p5 by, here repetitions are there, right? Yes, we have repetitions. What it is? T was there for 2 times, so 2 factorial. T was there for 2 times, so 2 factorial. I hope you understood this one. No 2 vowels come together means this is the case. This is the case of no 2 vowels coming together. Okay? Right. We will see our next case. See here, students. Whenever there are only 2 vowels in the given question, no 2 vowels case, and vowels not together case will be same. Am I correct or not? Whenever there are only 2 vowels, no 2 vowels case and vowels not together case are same. Is it correct or not? Yes, it is correct. Why? Because there are only 2 vowels. Vowels not come together means they will come individually, and no 2 vowels come means also they will come individually. So when there are only 2 vowels in the given question, so no 2 vowels and vowels not coming together, both are same. You will get the same answer if you solve with both of them. Okay? Right. Now we will see the next case. In how many ways the letters of the following words can be arranged such that always the vowels occupy odd positions? Now this is what is the condition here? Vowels should occupy odd positions. So first of all, please see here detail 1, 2, 3, 4, 5. So total how many letters are there for me here? 6 letters are there. 6 letters are there. And how many vowels are there for me here? 3 vowels are there for me. What are consonants and vowels? D, T, L, E, A, I. How many consonants and how many vowels I have here? 3. So there are only 3 chances for me. 3 and 3. Luckily here I have 3 part each. So 3 consonants should occupy even places and 3 vowels should occupy odd positions. So what you will write here? 3 factorial into 3 factorial. Why? Because for consonants there are only 3 positions. What are those? Second, fourth and sixth. 3 letters in 3 positions. Actually what is the formula here is 3p3 into 3p3. Actual formula is 3p3 into 3p3, but directly I have written as 3 factorial. This is for consonants and this is for vowels. Okay, sir, good. We are done. Now come to this machine. Machine, we will write here, machine. How many letters are there actually for me? 7 letters are there. So 1, 2, 3, 4, 5, 6, 7. So in 7 positions, how many odd positions I will have? How many odd positions I will have? 4 odd positions I will have. 4 odd positions I will have. But how many vowels actually I have here? M, A, C, sorry. I'll write vowels and consonants separately. M, C, H, N, A, I, E. I'll write them separately. So M, C, H, N. How many first vowels I need to fill? Here my priority is vowels. Why? Because vowels should definitely occupy only the odd positions. Vowels should definitely occupy only the odd positions. So in that 4 odd positions, I should arrange those 3 vowels. In how many ways I can do it? 4P3. Why? Because 4 odd positions and I have 3 vowels. And next into, when it comes to this remaining 4 consonants, it can be arranged. See, there is no rule that, see, what happens actually here is definitely one consonant will occupy 1 odd positions. Am I correct or not? Why? Because I have 4 consonants and I have only 3 even positions. What about that 4th consonant? Definitely it should occupy the odd position. There is no other choice. There is no condition that this consonant should not occupy odd positions. Yes, consonants can occupy the odd position. There is no doubt in that. Consonants can occupy the odd position. So here what did we can write? 4P3 into consonants. 4 consonants are there. There is no condition for consonants. So directly I will write they will be occupied in, they will be arranged in 4 factorial ways. So 4P3 into 4 factorial. 4P3 into 4 factorial. Or else if you want it, write it more precisely, you can write it as 4P4. Anyway, both are same students. It is waste of time in writing 4P4. 4P4 means 4 factorial only. Okay. Now come to this pounding. Please try to write the answer for pounding. Similarly, please try to write. So total 1, 2, 3, 4, 5, 6, 7, 8 are there. So in 8 positions, how many odd positions we will get? 4. So 4 odd positions are available. So how many vowels are there? 1, 2, 3. 3 vowels are there for me. Okay, good. So in these 4 odd positions, 3 vowels means 4P3 into how many consonants are there? 5 consonants are there. Those can be arranged in 5 factorial ways. Or else 5P5. Anyway, that is same 5 factorial ways. So in these many different ways, we can arrange the conditions. That means whenever we have the questions on like this, first of all, we should fulfill the condition and then only we come to the remaining things. For example, if the questions are based on always the consonant should occupy odd position, means first of all we will arrange the consonants in odd positions and then we will see about the vowels. Understood? Right. Next one. How many ways the word playground can be arranged such that, okay, there are some conditions. Playground total how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And is there any repetition? No, there is no repetition for us here. There is no repetition for us, so no need to worry. So in how many ways the letters of the word playground can be arranged? Such that first condition is if the word starts with Y. That means my first position is fixed for Y. Out of 10 letters, 1 letter is fixed here. 1 letter is fixed here. So for the first position, how many chances I will have? Tell me students, only 1 chance. What is that? Letter Y. I should fill definitely it with Y only. So how many chances? 1 chance. Now from the second position onwards, all these are without repetition only students. All the problems which we are solving without repetition. So out of 10 letters, Y is already fixed, right? So for my second position, 3rd, 4th, 5th, 6th, 7th, 8th, 9th and 10th. How many chances will be there for my second position? 9 chances. Why? Because already Y is fixed there. I will be left with more 9 letters. Among those 9 letters, I can fill anyone in the second. Next, 8 chances. Why? Because already 2 are filled. 7, 6, 5, 4, 3, 2, 1. This is nothing but 1 into 9 factorial, right? Why? Because for the first position, only 1 chance. Only 1 chance. And from there onwards, 9 factorial ways. So 1 into 9 factorial will be our answer here. Next, when it comes to this one, if the word starts with Y and ends with G, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It should start with Y and it should end with G. So for first position I have one chance, for last position also I have one chance. Now tell me what will be my answer here. For second, third, fourth, fifth, sixth, seventh, eighth and ninth positions, how many chances I will have? Out of 10 letters, 2 are fixed, right? Y and G are fixed. So how many letters are left for me? 8 letters. So for the second position, 8 chances. For the third position, 7 chances, 6 chances, 5, 4, 3, 2, 1. So that means what I can write? 1 into 8 factorial into 1. The middle 8 positions I can write it in 8 factorial ways. When it comes to first and last, they are fixed with only 1 letters. Y and S. Understood, students? Now, the word should start with a vowel and end with a consonant. Right? Vowels and consonant. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 10 letters are there. Total how many vowels and how many consonants are there here? Vowels we will count 1, 2, 3. So for the first position, how many chances I will have, students, here? I will have 3 chances. For the first position, how many chances I will have? 3 chances. When it comes to last position, how many chances I will have? 7 chances. Why? Because I have 7 consonants. Out of 10 letters, if 3 are vowels, means remaining 7 will become consonants. So 3 and 7 chances. Now out of 10 letters, 2 are fixed. It can be anything. 1 vowel and 1 consonant are gone. So now how many chances I will have for this? I will have 8 chances for this one. I will have 7, 6, 5, 4, 3, 2 and 1 as usual. So what will be my answer in this case? 3 into 8 factorial into 7. 3 into 8 factorial into 7. Understood? Right. The next one. No 2 vowels come together. That means what? First of all, I should arrange the consonants, right? Consonants. So 7 consonants are there for me. 1, 2, 3, 4, 5, 6, 7. So 7 consonants can be arranged in 7 factorial ways. Between these 7 consonants, how many gaps we will have? One more than that, right? I will have 8 gaps. In that 8 gaps, I need to fill how many vowels? 3 vowels. So 7 factorial into 8p3. 7 factorial into 8p3. Understood, students? Till now, all the concepts which we have learned, we are applying on this question. Next, vowels occupy only odd positions. Vowels occupy only odd positions. Then what we are going to do? See, total how many are there for us? 10 are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are there. In 10 positions, how many odd positions do we have? 5. And how many vowels I have here? Only 3. So 5p3. Vowels will occupy in 5p3 into, and the remaining positions will be occupied by consonants. 7 positions will be left. They can be arranged in 7 factorial ways. So 5p3 into 7 factorial will be the answer for the last question. Right? Understood? I hope it is clear for everyone, students. We will see the remaining things. See, this is regarding completely permutations. We discussed everything based on permutations concepts only. Okay. For your understanding, I have told in this manner. Okay. Next, we will see the combinations. We will see the combinations. And then we will see the problems based on the combinations. I hope it is clear for everyone, students. We will see. Not permutations is not yet done. Still there are some other questions. We will see later. Thank you. Thank you very much.